Today, we will talk about normal distribution. Now, when the distribution shape is symmetric, we're going to call that a normal distribution. Oops, missing that here. Again, if you see a distribution shape and you see that it's symmetric, that is called a normal distribution. Now, it is important for us to understand normal distribution because it's one of the most important distributions in statistics, and we're going to see its properties today. But one thing to keep in mind is that when you've been given a normal distribution, there will always be a 100% underneath the graph. We are going to look at the area underneath the graph, and obviously, the area underneath the whole graph is going to be 100%. So keep that in mind. Again, we will be looking at the area underneath the graph, and if you look at the area underneath the whole graph, well, that's always going to be 100%. So now, let's get started. Before we look at this graph, let's pay attention to the following, which is notation here. There's going to be two Greek letters that we're going to be using when we're talking about normal distribution, and that is mu. And mu, we're going to use that to represent mean. So instead of writing the word mean, we're just going to write the Greek letter mu. And instead of writing standard deviation, we're just going to write the word or the Greek letter sigma. So once again, this is just notation. If you see a U, it's called mu, Greek letter, and we're going to represent mu for the mean. And sigma, we're going to represent that for standard deviation. Because when we talk about normal distribution, all you need to know is just the mean and the standard deviation. So we're going to use this two notation now. Now that notation has been clear, let's come back to the overall example here. So again, just like we said in the beginning, underneath the graph, there's always going to be 100%. Now, notice that here it's the same graph, but now it's been categorized in different sections. Well, one way to see it is the following. Always identify the mean. The mean is always right here in the middle. So this is the mean. Well, should have been a little bit straighter, but you get the point. So that's our mean. Our mean, you can think about it as some kind of a starting point. Now, if you are on the mean and you decide to add one standard deviation, the first section that you will create, that's going to give us 34%. So if you're in the mean and you move one standard deviation, you will gain 34% of the overall graph. If you decide to move another standard deviation, on that second step, you will gain 13.5 of the overall 100. If you decide to move another standard deviation, you will gain 2.3%, and whatever's left here, this little area underneath the graph, is nothing more than 0.15. So if you want to move to the right side of the graph, you will be adding standard deviation. But now, what if we go the opposite? Again, you're always going to think about it as the mean, should think about it as some kind of a starting point. So let's go back to our starting point. Now, what happens if from your starting point, you decide to move to the left? Now, if you're moving to the left side, you're going to be subtracting standard deviation. So if you subtract one standard deviation, you will gain 34%. If you move another standard deviation, now you will gain 13.5%. If you move another standard deviation here, you will gain, oops, if you subtract another standard deviation, you will gain 2.35, and whatever the area that is left here is nothing more than 0.15. So again, if you add all these areas or all these percentages, it should always give you 100% because all we did, you know that underneath the graph, there's always going to be 100%. So all we did, we just broke down that 100% into pieces, and each piece is being determined by how many standard deviation you move in either to the right or either to the left. Again, if you're in the mean and you move one standard deviation, you will gain 34%. If you move another standard deviation, you will gain 30.5, and so on. And if you move to the right, it's adding standard deviations, and you move to the left from the mean, you will be getting the following percentages in blue. So now, how can we put this idea into practice? Well, let's look at some examples here. Now, this is what it says, the following. Now it says 500. Let's move the graph here to the left. So now notice that what we have here, it says 500 juniors at Central High School took an ACT last year. Now it says that the scores were distributed normally. Now this is an indicator that we're going to be using normal distribution because it's telling you right here, it's being distributed normally with a mean of 24 and a standard deviation of 4. We're going to do two things. First, we're going to label the following normal distribution just using 3 standard deviation, and then we're going to answer the following. Again, when it comes to normal distribution, you really just need to know 2 facts, and that is, what is your mean and what is your standard deviation? Now, from the word, for like the problem itself, it says here, the mean is 24. So again, this is mu for the mean, and the standard deviation is 4. Now, if we want to label the graph first, your mean, which we know is 24, it's always going to be right here in the middle. So notice that this section is right here in the middle. So this is telling you that the value underneath this is 24, because we know that the mean is 24, because the mean, it always goes in the middle. So now, if we want to find out the next section, we need to add, we know we're moving to the right, so we need to add 1 standard deviation. We know that standard deviation have a value of 4. So if you're at 24 and you move 1 to the right, that's going to give you 28, because you're adding 4 if you're moving to the right. And if you move again to the right, to the next section, that's going to give you 32. And if you move once more, that's going to give you 36. Excellent. So now we need to label the other side. Again, you're going to come back to the mean, which right here is 24. And from the mean, if you move 1 to the left, now we're not adding standard deviations anymore, because if we move to the left, you subtract standard deviation. Knowing that the standard deviation is 4, so if you're 24, you subtract 4, now you will be at 20. You subtract 4, now you will be in 16, and you subtract 4 once more, then you'll be at 12. So this is our label. We got our label here. So we're done with the first task. We'll label the name, the mean, and 3 standard deviation. So now we can answer the following question. What percent of scores are between 20 and 28? Excellent. So now, let's identify where is 20 and where is 28. So notice that 20 is right here. So let's just do a line here. And notice that 28 is exactly right here. So this is what we have so far. So now, what the question is asking us is, what percentage of scores are between these 2 points? So in theory, what we need to do is find out the area that is covered between these 2 points. What percentage of the overall graph is between 20 and 28? This is what they're asking us here. But how can we get those values? We're going to come back to the original graph here that we explained earlier. You know that if you are on your mean, if you move 1 standard deviation, you will gain 34%. So you know that this section is going to give you 34%. And you know that you're going to get 34% as well on the first section on the right. So that means that if you want to know the percentage of scores between 20 and 28, you got to add the percentages between 20 and 28. So that will be 34 plus 34. If you add those two, you're going to get the overall area. So that says that the answer for here is going to be 34% plus 34%. And that gives me a total of 68%. Now let's take a look at another example here. It says 500 freshmen at a high school took an algebra test. Now we know that the scores were distributed normally. So since it says it's being distributed normally, we know that we're going to be using the normal distribution. And it says, what is the mean? Oh, I'm sorry, with the mean of 75. So let's write that down. We know here, oops. We know that the mean is equal to 75 and the standard deviation of 7. So the standard deviation is 7. Again, all you really need to know is what is the mean and what is the standard deviation. We're going to use that to label our graph. Now again, the first thing that we should do is label the graph. Excellent. Again, locate the middle point, which is right here. This middle point, we know that this is the mean, and we know that the value of the mean is 75. So let's label that here. Excellent. So now let's find out the other. If we want to get the next region, if we're moving to the right, we're going to be adding one standard deviation. So if you're at 75 and you want to know the value for the next section, it's going to be 75 plus 7 in this case, and that's going to give us a value of 82. You move once more, that's going to give you a value of 89. And if you move once more, you need to add another standard deviation, and that's going to give you a value of 63. No, I'm sorry, 66. Excellent. So now here we are in our standard deviation, on our mean again. If you want to know the next section, now we're not going to add standard deviation, but we're going to subtract standard deviation. So 75 minus 7, let's do that in red, that's going to give me 68. If we subtract 7 once more, that's going to give us the next section, which in this case is going to be 61. And if we subtract 7 once more, we're going to get 54. Excellent. So now we can answer the following questions now. It says, what percentage of scores is less than a score of 61? So now in this case, we want the percentage of scores which are less than 61. So now notice that here we have the value of 61. So let's do our line here. So this is what we want. If we want the percentage of scores less than 61, then we want to know what is the percentage on the left side from 61, because left is less. So how can we figure that out? Well, one thing that helps me is to just label the whole graph, at least from the left side, since we're only working with the left side. So once we have this label, let's just plug in the values here. You know that the first section is 34. So here we have, this section is 34. You know that your next section has a value of 13.5. You know that your next section is 2.35. And you know that the little space at the end is 0.15. So like a little space here. And this still on the left side of 61, so we need to take it in consideration. So that's 0.15%. All right, so if we want the percentage of scores which are less than 60%, that will be this area plus this little area on the left as well. So let's just add them up. So now we're going to get 2.35% plus 0.15%. So if we do this correctly, this is going to give us that's 40, that's 50, 2.50%. Excellent. Forget about that problem. Now here, this is all we're going to discuss about standard deviation and normal distribution. So now Here's your entrance ticket. Try to identify your mean, your standard deviation, and now your question is what percentage of scores are between 61 and 82%?